Hello again, my friends. So here we are going to study the least unit cost heuristic, which is a little bit different than the silver meal heuristic. Okay. Now, in the silver meal heuristic, remember what we were doing. So compared to that, I'm going to explain the difference. So the silver meal heuristic is always calculating the function rho t, which is the average periodic inventory cost if my order is to span the demand of the next T periods, right? So we calculate this cost if my order spans the demand of the next T periods, that is the associated total inventory cost, including the ordering and the inventory carrying cost, and we divide that cost to the number of periods that is to be spent. So this is the periodic average cost, okay? Now, the least unit cost heuristic is a little bit different than that. It does not calculate the average periodic cost, but it calculates the average unit cost. So it is going to divide this cost to the total demand amount, okay? Not the number of periods that is spent in this cost calculation. It divides it to the total amount of demand which is involved in this cost calculation. Okay, so this is why it is called the least unit cost. Okay, the idea is the same, the iterations are the same as the silver meal heuristic. Instead of choosing the order interval which minimizes the cost per period, we choose the order interval that minimizes the cost per unit of demand. So we are just going to do the same things, but this time we are going to evaluate the average cost per unit as opposed to the average cost per period. Okay. So we are going to stop our computation whenever this function starts to increase as well, because let's see. In this calculation, so let's skip to the general formulation. I'm just going to come back to the previous slide again. So as you increase more and more periods in your order, we say that the fixed cost here, K, will be shared by all units included in this order, all the demand included in this order. So that function is going to decrease for a while, but as you increase more and more periods in your order, in that case, the inventory carrying cost is going to increase very fast. And even if you introduce the demand here, that demand will be multiplied with a larger integer value. Here, the demand is introduced in the denominator by multiplying it with 1, but here it is multiplied with t minus 1, and t is always going to increase if you introduce new periods in your calculation. So here's the thing. If my order is to span the demand of the next period only, then I'm just going to pay a fixed ordering cost, and this fixed ordering cost will be divided by the total demand in this period only. Okay, so that is the average inventory cost per demand unit, per demanded unit, if my order is to span the next period only. Now, if my order is to span the demand of the next two periods, then I will pay a fixed ordering cost plus the inventory carrying cost to carry the inventory of the next period's demand. And since I'm carrying it for one period, I'm going to multiply it with H. Now, this total cost will be divided by the total demand in the following two periods. Now, we expect gamma 2. Now I am using another notation because rho is already used for the silver meal heuristic. Okay, here I am using gamma, and this gamma 2 is always expected to be less than gamma 1. Okay, in general, actually it depends on the values that we have here, but again, as we introduce a new period, we expect to have a decrease in the gamma function, but at some point it will start to increase again. Now, if my order spans the requirements of the following 3 periods, then I will pay a fixed ordering cost plus the inventory carrying cost associated with the demand of the next period, but I'm going to carry that inventory for one period only. And I will pay the inventory carrying cost associated with the demand of the third period, and that portion of the order will be carried in inventory for about 2 weeks. So I need to multiply it with 2H again. Now, the numerator part is obviously the very same as the ratios that we have calculated in the silver meal heuristic, but the only thing changes here is the the denominator. In the denominator, we see that we are always we are always dividing the cost by what? By the total demand that is spent by that order. If we spend the demand of the following 3 periods, then we need to divide that cost to the total demand in the following 3 periods, basically. So the generalized gamma function here is this. If my order spans the demand of the next T periods, then I need to pay a fixed ordering cost plus the inventory carrying cost for the demand of the next period, H times D2. In order to carry the inventory for the third period, I need to multiply the demand with 2H. If I'm going to carry some portion of my order to meet the demand in the T period, then I need to carry that portion for T minus 1 periods. So I'm multiplying this with my unit inventory carrying cost for 1 period with T minus 1 and dt. The total cost will be divided by the total demand spent by that order. And at some point, when you introduce a new period in this calculation, the gamma t plus 1 will be greater than gamma t, and this is the point where we stop and we say that t is the optimal number of periods that we need to span when we plan an order receipt at this point. And we are going to start this process again, just like in the silver meal heuristic, in the next period. So let's solve the same question based on the least unit cost heuristic. Remember now, our first net requirement is observed in the second period. So this is the first period for this order, okay? So we need to plan an order receipt in the second period, and right now this is the first period in our problem, okay? So if my order spans this period's demand only, then I'm just going to pay K $100, and it will only meet the demand of this period, which is 30 units. So average cost per unit of demand is 100 divided by 30, which is 3.33. Now, if I introduce the demand of the next period in my order, then the total associated cost is going to be 140 because 40 units of inventory will be carried to the next period. And I'm going to divide this value, the total demand associated with this order, which is 70. And my average cost per unit will be reduced to $2. Now, if I introduce the fourth period, the cost will not be affected from that because there is no demand. And the total demand will not be affected from that because, and you see again, 140 will be divided by 70. The calculations will not be affected. And this value will stay the same as $2. And we do not observe an increase, so we should continue, okay? As long as it does not increase, we should continue, okay? So if I introduce the demand of the fifth period in my order, then I'm going to pay $170 of costs associated with 10 units. I'm going to carry 10 units of inventory for 3 periods, and the weekly unit carrying cost is $1. Therefore, my total cost will become 170 divided by the total demand of 30, 40, and 10 is equal to 80. The summation is equal to 80. When you divide 170 to 80, you would get a 2.13, which is larger than the average cost per unit calculated for 3 periods. This means at this point, we need to span the demand of the following 3 periods, okay? So I need to release 30 plus 40 plus 0 units of inventory, units of an order at this size. I need to release 70 units, and planned order received at this point in the second week must be 70. So if you do it like this, there will be another net requirement observed in the 5th week. Now, if at this point, if you plan an order receipt that spans the demand of the 5th week only, then there will be $100 of fixed cost divided by 10 units of demand. So the average cost per unit will be 10. If your order spans the demand of the next period as well, then the cost associated with that will be $40 larger because you are carrying 40 units of inventory by paying $1 per carried unit. And the total demand that is spent in this order will be 10 plus 40, 50. And 140 will be divided by 50 is 2.80, which is a lot lower than 10 here. If your order spans the next period too, in that case, your total cost will be increased by $60 because for these 30 units of demand, you need to carry 30 units for 2 periods consecutively in that order, and your cost will be $200, and the total demand that is spent will be 80. 200 divided by 80 is 2.50. And if your order also spans the 8th period, there will be nothing affected in cost calculation and in demand calculation as well because the demand is 0 here. It will remain, the average cost per unit will remain 2.50. Now, if your order spans the 5th period here, these 30 units of demand must be carried for 4 weeks, starting from the 5th week to the 9th week. So you need to pay $120 more, which makes your total cost $320. It should be divided by the total demand of 10 plus 40 plus 30 plus 30 here, 110, and the average cost per unit will be increasing at this point, 2.91. So this means this order receipt that we are planning here must span the following 4. So because this is the value at which we observe an increase in the average cost per unit. So this is the last value. The planned order received at this point must span the net requirements of the following 4 periods. So it will span this 10, this 40, this 30, and this 0 units of demand, which will be equal to 80. Which means at the 9th period, there will be another order received, okay? Now, if my order received here only spans this period, then the fixed costs of $100 will be shared among these 30 units of demand. Again, we will have a $3.33 of average cost per unit. If your order spans the next period's demand as well, then your cost will be increased by $55 as you carry 55 of units of inventory to the next period, and the total demand that will be spent by this order will be 85. The average cost per unit will be 1.82. So again, we observe a reduction in the average cost per unit. We do not go further because this is the end of our planning horizon. This means the last order received must span everything, every demand, all demand until the end of the planning horizon. So 85 units will be released here, 30 units will be met, and remaining 55 units will be carried to the next period. So please be careful. At this point, you need to write carefully how many units of inventory will be carried to the next period. For this solution, I haven't explained those. But once again, if you receive an order of 8 units here, 10 units of demand will be met. This means to the 6th period, we carry 70 units. After meeting the demand of the 6th period, 30 units will be carried to the next period, so on and so forth. So you need to be very careful about such calculations, but you have already seen such calculations in materials requirement planning studies in production planning courses. So, and if you do not remember, maybe it's a good idea to make a review on the materials requirement planning topic in your course. Now we have 3 order receipts planned here, for which we need to release 3 separate orders. For each of them, we pay $100 of fixed cost. So my $300 here is the total number of fixed cost that I need to pay. And from the 2nd week until the 11th week, the total amount of inventory carried from one period to the next is 195. And for each of these, we pay $1, and the total inventory cost is $495. Now, please check. It is a little bit larger than the cost we have calculated by the silver meal heuristic. Okay, so for this problem, for this instance, silver meal heuristic wins against the least unit cost heuristic, but that is not always going to be the case. There are some other type of problems, other type of instances where the least unit cost will do better than the silver meal heuristic. We cannot simply say that silver meal heuristic will always dominate the cost of the least unit cost heuristic. And unfortunately, there is no way of telling that without making such calculations, okay? So by looking at the demand pattern without performing any calculations related to these heuristics, without iteratively running these heuristics, we cannot simply say which one will win. But I mean, with experience on that field, at some point, you may have an idea when you check the pattern without making even calculations. You may most probably say which one is going to win, but that does not mean one of them will always be better than the other one. Okay, so this is the end of the least unit cost heuristic. There is one last heuristic that we are going to study, which is called the part period balancing heuristic, which I'm going to mention in my last video.